It's an old mystery yet to be solved, deciding who got to North America first and when they got here.
We had always assumed that it was modern Homo sapiens that came into North America relatively late.
A group of scientists find ancient mastodon bones in scenic San Diego, California, evidence that leads to a radical new theory about humans arriving in North America.
We have the bones, the fossils, the distribution, the rocks, the date. We have evidence for humans in North America 130,000 years ago. We realize that that is a startling claim.
And 1,000 miles north, other scientists explore routes that early humans may have used to get here. Perhaps ancient pathways buried deep beneath the sea.
The problem is that there's no way for us to exactly know whether or not people have come down the coast, for example, or not, until you've given it a really good look. And we have not done that yet.
Finding the answers is a painstaking process. And the new theory is creating fault lines across the scientific community about the history of humankind.
The study of early humans in the New World has been very political and very controversial for over 125 years.
It's an exciting claim. Let's get it out there and let's let the scientific community evaluate what we're doing.
For much of the 20th century, archaeologists generally agreed that the earliest people to populate North America were the Clovis people, dating back to some 12 to 13,000 years ago. Then, in April of 2017, a group of scientists in California make a surprising announcement.
Welcome, and thank you for joining us this morning at the San Diego Natural History Museum as we share some exciting news about a discovery made right here in San Diego.
The team says these artifacts, now on display at the museum, reveal that early humans made it to North America 130,000 years ago. More than 100,000 years earlier than anyone previously thought.
The 130,000-year age of the site that's really the most extraordinary result of our research. And I realize that 130,000 years is a big number when we're thinking about the early peopling of the Americas.
This scientific bombshell began unfolding when California Department of Transportation workers uncovered a surprising find while working on a highway.
Back in 1992, Caltrans was doing improvements to State Route 54. Richard Cerruti, who's a field paleontologist here at the museum, was monitoring excavations on the very north side of the freeway alignment and saw this little puff of tusk material being scraped up by an excavator and said, "Stop, let me go look at this."
The tusk that Richard Cerruti found belonged to an ancient mastodon, one of millions that used to roam North America until they were driven extinct by hunting or climate change, roughly 11,000 years ago. But that wasn't the only artifact Cerruti and his team uncovered.
We were exploring that initial discovery, and in the process uncovered not only tusk material, but some bone material and some rocks.
The occlusal surface of this cone of this molar has been broken totally away, so you're seeing the dentine. This explains why we're getting these little fragments of enamel throughout the site, but it doesn't explain the mechanism as to there are anomalous fragments of rock, anomalous fragments of tooth enamel scattered throughout the site that just don't make sense in a natural depositional environment.
So this juxtaposition of these objects is not typical, and we felt that it was important to produce a map of the site where we precisely plotted the position of all the bones and the stones or whatever else is in there so that we can understand what the general pattern is. This is a map that summarizes what we found at the Cerruti Mastodon site. So this rock and that rock fit together, and they broke on that angle right there. And these are the tusks of the mastodon, a single individual. One horizontal and the one we looked at is vertical. Another anvil. And the scatter of broken bones, including spirally fractured bones. And over a 5-month period, this picture emerged.
The picture that emerged indicated to the museum scientists that the mastodon bones had likely been broken apart at the site after the animal's death by several large cobblestones that were used by humans to smash them.
The thing that is impossible to explain at this point, hydrologically or geologically, is the presence of these big boulders in and intimately associated with the bone.
So this is one of the cobbles that we hypothesized was used as a hammerstone. And you can see it's a circular or disc-shaped cobble. And if you look closely, there's some striations coming off of that are indications of where this flake has come off. I like to think of this as kind of a MacGyver moment 130,000 years ago where there was a carcass of a mastodon. These people were trying to recover raw materials from it. They had a problem. How do we break these bones? They look over into the active river channel, find some cobbles of the appropriate size and weight, bring them back to the site.
Almost 2 decades after the mastodon's discovery, Desmarais sent several of the mastodon bones to Jim Paces at the U.S. Geological Survey, who used state-of-the-art radiometric dating to determine their age.
So what do we got in here, Steve?
Looks like vertebra.
It does.
We conducted hundreds of analyses on the specimens sent from the museum, and we came to the conclusion that they were broken while they were fresh, and that had to be about 130,000 years ago.
The proof that humans may have arrived in North America more than 100,000 years earlier than previously thought is far from conclusive. After all, no actual human remains from this era have been found. But Dr. Stephen Holland says the evidence is compelling. He was part of the team that evaluated the findings from the San Diego excavation.
I said, I can't get my mind around this. This site has to be really, really old, but yet here's evidence of humans. I said it goes against everything I thought I knew and everything I have ever been taught, but yet here's the evidence right in front of me, and I now have to deal with this.
Holland evaluated the mastodon bones and the hammerstones recovered from the site.
When my wife Kathleen and I first came out here, we would take the drawers out of the cabinets in here and bring them in on this table and look through them, paleontologists and archaeologists together. And we would look through and we would look for these very diagnostic pieces. And one of the things that we got all excited about first were these cone flakes that form in a circle around the point of impact from the hammerstone.
Holland specializes in evaluating broken bones at archaeological sites, looking for human causes, as this video shows from earlier experiments he conducted in Africa.
Oh my God.
Breaking an elephant femur with a big hammer, we saw the same kinds of fracture patterns that we did experimentally.
As we puzzled over this, we kept coming back to this one, what we would say the most parsimonious explanation that explains all the data, was that humans did this.
Oh, I hear it. Sounds good, you know.
It's coming.
I see it. Whoa, good
Got it.
job.
Finally.
The team at the San Diego Natural History Museum remains confident in their findings. But if humans did arrive in this part of North America more than 100,000 years earlier than previously thought, then who were they? And how did they get there? This is what a different team of scientists in Oregon hope to answer. They're conducting innovative research that could completely reshape our understanding of how humans migrated across the globe. Their work is focused on a period thousands of years ago when a buildup of thick glacier ice on land caused ocean levels to fall several hundred feet.
The idea is that as the first peoples came either across what would have been an exposed land bridge between Siberia and Alaska, they could have walked across, they could have skirted the edge, they could have theoretically paddled their way along the edge, but they would have come down onto a part of North America that had a large piece of ice on it. This ice is so enormous that it sort of gives them a substantial obstacle. So we're looking at the edges, and there's two competing ideas. One is that people may have been able to come through a gap between the two ice sheets. People may have also been able to paddle themselves along the edge of the Alaskan archipelago down into British Columbia.
Scientists have generally agreed that the Clovis people got here first, following the last ice age. And new evidence pushes this time back at least 1,000 years. But even this might change. Researchers are now looking offshore for evidence that the true first Americans may have walked much earlier on land that is now hidden beneath the sea. It will take good detective science to prove this. Dr. Lauren Davis and his team are combining field research with Geographic Information System Technology, or GIS, to search for ancient human pathways that were once above the current sea level.
We can use some of these emerging technologies that are being developed in other fields, like oceanography, for example, the development of autonomous vehicles that you can load up with equipment that do things like see into the seafloor. And we can make more sense of it, and we can get better refined models for getting better guesses as to where sites could be.
We have more and more powerful computers and more powerful software applications, and we're collecting new types of data all the time.
One of Davis's former graduate students, Alex Nyers, is helping to construct a comprehensive model of the coast from Alaska to the Mexican border that can predict ancient shorelines dating back to the last ice age.
This is the modern Oregon coastline as it is today. And we have over here the way that we project that the landscape was 20,000 years ago. Included in that are our stream networks as our model predicted. And we can zoom in on one feature here. In Newport, we have the Yaquina River. And if we pan over, we can see the modern river here. And then our model predicts where the previous river channel would have been in the paleo landscape. And this is 20,000 years ago. And then we can see where we project that it might have gone based on current bathymetric data.
Bathymetry is the measurement of land that lies beneath bodies of water. Nyers uses these data in the GIS model to locate ancient riverbanks and coastlines where humans likely would have settled.
We need to actually go out and start ground truthing this model, and then using the data that we collect in the future, refine the model down to a point where it's better and better at predicting where people might have been in the landscape.
Davis and his students enter topographic data about the modern coastal region, including the location of current rivers and estuaries, to help build the GIS model. A river that ends at the ocean just might lead to evidence of ancient people far from the current shoreline.
This is the Yaquina River, and it meets the ocean here at Newport, but it hasn't always been that way. In fact, in the past, as sea level was lower, this river would have flowed out 35, 40 extra miles away. We can now take our computer model, where we've reconstructed the course of the Yaquina offshore. We can follow its course with a ship and look for archaeological sites along the banks of this ancient course.
They will use this GIS model to follow the predicted paths of the old offshore river systems in search of any evidence of early human activity. Today, they're on the exploration vessel Nautilus, which has special equipment to explore the bottom of the sea.
It's got really great remotely operated vehicles. One's called the Hercules and the other one's called the Argus. And together these two machines work as a team to give really great views of what's down on the bottom of the seafloor. Being able to take the ROV down and look at it more closely helps us ground truth, as it's called, the patterns that we see on the screen in relation to how they are in reality. Once we get down on the bottom of the seafloor with an ROV, we may see things that look like rough patterns in the geophysical data. It could be places where there's gas, for example, seeping out of the seafloor. It could also be a pile of shells from someone creating an archaeological site in the past. We won't really know until we get down there and look at it.
Once a promising site is identified, the scientists will return to collect core samples from the seafloor. The cores might reveal material left behind by ancient humans. They know this is possible because the same kind of evidence they're looking for offshore can be found on dry land left by humans just a few thousand years ago.
The work we do on land gives us this perspective of what archaeological sites might look like offshore. So here behind me, you can see a shell midden. This is a layer of shell left behind by people just a few thousand years ago because the ocean was pretty much at this position. Now imagine the sea level being so much lower. We follow one of these streams out on the edge of where the river meets the water of the ocean, and that's where people would be collecting shells. And if we can just trace out some of these rivers out to the west, what we'll do is look for places where they're doing this kind of activity. And as we put a core into the seafloor, this is what we might expect to see.
Molly Kirkpatrick is a graduate student at Oregon State University. She's analyzing core samples from a current shoreline site called Taconich Landing to learn more about the shell midden deposits they hope to uncover offshore.
A shell midden is a refuse pile where people were hanging out, eating, and doing their daily activities. So this portion represents the surface. This is most recently deposited. And then I think this area is most likely disturbed material near the surface. And then here's where the real cultural signature begins. Within this, there's a really dense period. You can see it's really chock full, and then here it's a little bit more scarce. But this I've classified as entirely shell.
The amount of spent shells in these cores provide a strong indication that a thriving population once lived here, which means they become a window into how they survived.
These are not just deposits, these are people's ancestors. And so it's, I think, not only for the archaeologists, but for the living community, it means a lot to learn something about history that, may not otherwise be inaccessible.
So what we've been able to do with Molly's work at Taconich Landing is we actually found, through coring, where the old river course was, in the woods. It's actually buried under a dune, and you can't see it at the surface. So in a lot of ways, this approach that we've done with Molly's work is a lot like what we're going to do offshore.
The results of the offshore work look promising. So far, their models correlate well with what appear to be ancient buried shorelines. The next phase will be to get core samples from the ocean floor to see if they can detect any sign of ancient human activity.
Oregon State University has a research vessel called the Pacific Storm, and we'll use this research vessel to go out and evaluate our model, a model that suggests that there could be sites out there in parts of this ancient landscape. We'll position the ship over the top, we'll drop core rig down onto the seafloor, flip a switch, it'll push the core into the ground, and we'll winch it back up onto the ship, look inside the barrel to see if we're actually finding the sites that we expect should be out there.
And if scientists find new evidence about who the first Americans were and how and when they got here, their work could completely reshape some of our most basic assumptions about the history of humankind.